Okay, continuing from the previous session again. Okay, I will I won't be able to repeat this again. I hope that you can calculate this, right? You can calculate for the C1. Okay, again we are calculating the line integral for the work has been done by the goes here. Okay, from here O to the B. Okay, we already calculated for the C1, we already calculated for the C2. Now we wanted to calculate for C3. Okay, C3 here. Okay, therefore the calculations here, if we start using this calculation here, we will get the solving this part. I just stop, right? Let me calculate this part anyway, just to finish it. Okay, that is a 32x4 dx. Therefore in total we get this one, okay, 9x3 3, okay, 10 plus 3 32x5 over 5. This will give us 10. Therefore we get 32.5 and in total 47.5. Therefore this equation here, okay, is giving a kind of shadow here. Okay, therefore overall we have done C3. Is it C1 plus C2? That's our question, right? Therefore when this is 7, 47 over 5, 47 over 5 not equals to 1 over 3 plus 8. Okay, it's not equals. Therefore the weight that from here what can we conclude here? The work to be done definitely from moving from A to the B is not equal to OA A to the B. Okay, according to the calculation that we found here. But it's very interesting, and later you will get something very different solution, whereby this is a path dependent. The solution is basically a path dependent, we call it. Okay, later we're going to calculate path independent. Okay, I will explain to you in detail about this later. Okay, this is a path dependent. That means, you see, when we move, we use a different path. It may give you different work to be calculated. That means, or different work to be given. Okay, now with this we managed to conclude to the method 2. Okay, method 2. Now let me proceed to method 3. Okay, method 3. It's all can be shown in one single things, but I'm trying to show you step by step to differentiate. You see, what is the logics making the formulas differently used. Okay, method 3 is something that we're going to use based on FDR, but the difference that I'm going to show you is this. Okay, you see, I'm going to combine method 1, method 2 in the method 3, or there is a slight difference here. Okay, I'm going to show you slight difference here for the method 3. What is the slight difference that I wanted to emphasize here is something like this. Okay, let me put it to you this. Okay, this is not a method, but it's a continuation from the method 2. There is a slight difference. Actually, that's the reason I wanted to show you, because I want to show you vector equation for straight line. Okay, this is not common. Again, this method is not commonly used for our our subject, EUM 114. But if you see that in other books, okay, some different school, they may focus more to the vector, okay, calculation. Instead, they're focusing more to the manual algebra calculation. See, therefore this method, I start with the one example. Most probably is you may give let's say an object is it large? Can I make it a little bit larger? Okay, it's easier for you to see. An object acted by the force Fxy x2 is it x2 or x3? Sorry, this is x3i. yj moves along parabola. Okay, parabola y3x2 from the origin. Okay, from the origin to the point 1 3. Okay, find the work done by F. Okay, how the work basically can be calculated again. Okay, let us sketch this. The sketching will involve this F. Okay, 0 0. This is move up like that. This is the point B, and the point is something can be 3x2. And can I calculate this? Yes, very easy. Okay, if you use this is a 1, it's become a 3. Okay, this point is actually is a 1 3. Okay, but the equation is known. Where is the direction? Okay, the ghost is going up like that. Okay, or it could be a object, means it's not necessarily ghost, it can be any ball or object. Okay, the ball or object, but you can see it's climbing up based on the dr. Okay, I'm treating this as a now dr. Okay, now you have two options. Okay, you see, must be a same direction again. The ghost and the dr must be in the same direction. Therefore, the work can be calculated based on the F and dr must be in the same direction, whereby the F can be, this is the second method, this is the first, method 1, method 2. Okay, 2 dy F3 dz. Okay, can I use method 2 to solve this problem? Can. Okay, let me show you one by one. Okay, F is x3i yj. That means can I use this? Yes, you can use this method here to calculate this and combination to calculate this. But ultimately I wanted to show you something different, right? Okay, but let it be. How to calculate? I call it, this is option 1 and option 2. Okay, we calculate based on the option 1. Let me show you the option 1 that you already learned in a method 2. Okay, I call it, this is option 1, method 2. Okay, I use a method 2 to calculate option 1 and method 2. Therefore, when I use a method 2 to calculate, okay, this is F1, this is F2. Okay, if I wanted to calculate F1, F2 method, what is the important things here? Y is given. Okay, we take it, this is now an exercise. Okay, dy can be calculated as a 6x dx. Okay, can I calculate the w? Can. Okay, f dot dr, and substitute into the equation. I will get here x3 dx y dy. Okay, I put it here because I wanted to do the simple comparison later. Definitely you won't prefer the method 3 here. Okay, but I wanted to teach you this method 2 first. We are using option in the method 2. Okay, then this is one. Okay, my vision is here because which one do you prefer? Of course, I prefer because the changes is not good in the dy direction. Therefore, the best thing is to use x base. Therefore, I choose this x base calculation here, x2, 6x dx. Then this will give me 1 to the 0, x3 dx, 18x3 to the dx, where w is 14/4. Wow, easy to calculate, right? Then I think by now you already nearly got it, the logics. Okay, you got the logic to calculate the line integral for the method 2. Okay, you can see obviously now you know the logic already. Okay, now I'm going to teach you this. This is normally, again I remind you, the method 3 that I'm going to introduce to you is not common for our what do you call, in our schools. Okay, it's very rare we will teach you this, but because I'm teaching this method, the reason is basically because when you refer to other books, okay, the books may give you this kind of information, and which you definitely may get confused. Therefore, I wanted to help you to understand the books easily, comfortably with this various type of method. Okay, but I'm not introducing because of the book, because some questions may, okay, if may challenge you when you're looking at from the internet sources or other sources. Okay, now this, the option 2 that I'm going to introduce you is a method 3. I may call it method 3, but it's a vector base. Okay, it's a vector equation. We're going to use a vector equation to calculate. Okay, vector equation to calculate. Okay, one of the things here for the straight line, okay, for the straight line, the vector calculation, some cases this vector calculation will be calculated based on this straight line for the vector. For the, again this is for the fixed, okay, not for the curve. Vector equation for straight line, for straight line. Okay, therefore I can calculate the equation here based on the vector RT. See, I'm trying to looking at the curve point of view. We are parametrically, we are using a kind of parameterization. Okay, A. Okay, what is A? How do we calculate the A here? Vector. The A is is the A here? Okay, good. 2. Okay, the calculations here, just roughly we can calculate the A based on the 0 0. Okay, 0 0. Therefore 0I 0J plus T. What is B? The B is 1I plus 3. Okay, B is a 3J minus, what is A back again, 0I plus 0J. Okay, then we just insert, we need to arrange back. Okay, I want you to do this homework by yourself. The RT can become I 3J T. This is a straight line. Okay, 1I plus 3J, which it will give you T. Okay, this is a straight line. Again, remember, it's a straight line because we are using a straight line equation. I know you all will not happy with this equation. Where this equation coming from? This is a vector. Again, I remind you, it's a vector equation for the straight line. Vector equation for the straight line. If you refer to my my notes, I think okay, I will in my tutorial, if I'm not wrong, okay, I may able to show you this, but you refer to the vector equation for the straight line, you will get this equation anyway. Okay, but if you, as I already told you, if you're not happy with this equations at this moment, you can ignore, no problem. Okay, now if this is the case, okay, if this is the case, you can see this is the T and 3Tj. Okay, you will get here Ti 3Tj, right? Okay, this is the equation that you will get it. Therefore, the I basically is referring to, therefore you can see the RT. Earlier we start with the xt I yt j, right? Now this is, we got the equation. Therefore let xt be a t, y to be a 3 t2. Am I making t y? How do we t2? Where am I getting that t? Oh, I think I made a mistake here. Something I left 3 x2. Okay, y is a 3x. I miss x2. Therefore, when I start using this is 3x2. Okay, this if t we know, we just substitute with the y, we get a 3x2. But why we didn't get here? Wait, let me see this first. Okay, t straight line rt, but actually it's not correct. This okay, again I will put it here. Okay, y equals to 3x2. Okay, where am I made here? 1i. Is there anything that I made here? 3. This is something here. There is a mistake. Should be a mistake here. Wait, let me see. It's a 3. Okay, 1 3. Okay, let me put it to you this way. It's not straight away we are pulling. In this case, it's a 3x2. Okay, because if I just substitute this with the t, I get a 3 2. Okay, where the formula we will apply to, there is something that not correct, because the straight line is not oh sorry, haha, very important things here. This is not a straight line anyway. This is not a straight line, please, sorry. This is not a straight line. Therefore this RT is for the straight line. Okay, this is actually is a straight line. Okay, this is for straight line. I already mentioned for the straight line, but in our case this is not a straight line. Okay, this is not a straight line. If I straight, okay, this is the answer, but this is not a straight line. Therefore I use this combination, okay, together. If RT is a t, then I just pulled, okay, let xt to be the t and y to the t. Therefore I use this method formula to calculate here. Okay, I forgot absolutely, I forgot that I am dealing with the these things. Okay, but anyway, this formula is useful to you later. Okay, we are not going to use again in this particular case, we are not going to use, but we're going to use this method anyway. Okay, here therefore the parametric here, when I substitute the parametric, the t will be controlled. This is several times the student will ask me, why is it a 0 to 1? Okay, is it something like that? Okay, you just substitute and see first. Okay, is it working or not? Okay, for this, because the range can be calculated based on here also. Okay, when I substitute 3, okay, 0, I will get a y equals to 0, and I substitute 1, yes, okay, I get the extreme. Okay, I get the extreme. Therefore, this is correct. Okay, this is correct. Now, with this calculation, I should able to now substitute back. When I substitute inside to the RT, okay, when I substitute that inside the RT, here I get a T I T 3T2J. Okay, therefore what is the dr? Dr is okay, I just substitute here back dr, I get a I, right? Therefore I get a 1. This one is a 1, of course. This one is a 60, right? 60J, 1I T, and don't forget dt is there for the I. Okay, with that, can I combine now? Okay, now the first time you are seeing back again this formula, the first time you are seeing the f and dr. Okay, so many of you don't like this again. Okay, f to the dr, first time you are seeing back this. Okay, because in most of the cases you can see they will measure everything from the vector base. Okay, this is a vector, they will give you this in the vector, then you need to solve everything in the vector base. But I already suggested to you, you can convert the vector to, okay, method number 2. Okay, method number 2 you can calculate back, but as long as you know the curve. In this curve, in this case, the curve is not a straight line, but it's a curve. Therefore, is given. Therefore, we can calculate the RT. Okay. Now with this, we combine together. Okay, we combine together to calculate the f. F is a x3. You know. Okay, x3, I, y, j. First time you are looking at this. Okay, I plus 60j. Okay, for the dt. Then shall we able to calculate that? Yes, x3, okay, 60y dt. But of course, what is y? We already decided y is a t, and here y3. Just convert it everything. There you will get here t3 60 y is a 3t2 dt. Therefore, in total, you should able to calculate that as a 10 is a 10 t3 18 t3 to the d3. Therefore, the work is 19.4. Right? 19.4 cannot be 19.4. Oh, this is 19. Sorry, yeah. Just now I calculated here. This is a 19.4. Please, if you try, then you will get 19.4. Suppose you should get a same. Okay, this is 19, not a 14. Huh? Please, sorry, yeah. Okay, now we got the method number 4. Number 3. Okay, so far I hope that you can follow, then you can see the differences here, then you know the matching here, how to calculate up to various method. I introduced to you the combination, but you may say, sir, that method 3 is actually a method 1, right? It's a method 1, but what makes different here? Sorry, this method actually is not a different method anyway. I may say this, I'm introducing some kind of how to create the vector equation. Okay, This is the reason why I just call it this as a method 3. Okay, anyway, this is not a method. You can make it this as a first method, no problem. You may say, okay, I prefer to say this is a method. Okay, no problem. But I don't worried about method. Instead, you just concentrate, how am I solving the problem for the problem? Okay, therefore I'm using the method just to say how variation can be made, okay, in the questions. Okay, therefore I'm segregating the variation of problem solving into method. Okay, now with this, now we move to one simple conclusion that I may conclude to here. Okay, this is a very important conclusions, but let us try to summarize this idea. Two way of approaches that we are using here. Okay, two-way approaches we are using here. One is a vector base. Okay, one is a vector based. One more, we call it that as a scalar based. Okay, scalar based. Very obvious, we have done this, right? The early is the problem solving work can be calculated based on dr, and this is vector. For the force, call it F1 I, F2J, F3K, and this directly become method number 2, where we can calculate this to become F1 dx, F2 dy, F3 dz. Okay, now what are we going to do now? I'm going to okay, this is actually, it's not a method number 1, actually it's a method number, sorry, this is method number 3, this is method number 2. Now method number 1 I forgot. Method number 1 is a straightforward one, which is F times with the displacement, right? We learned this. Okay, now I'm going to introduce to you one more method in the scalar, which it will be calculated based on the number, can I call it this number? What method because I use that as method number 4. Okay, method number 4, where we calculate W as F dot ds. The first time you're going to see the ds. Okay, you can okay, is this a vector? No, actually this is not both are scalar, but can I say what is this dot means? Here is a dot product, am I referring to? Okay, is it a dot product? No, actually this one is a times. Sorry, can I remove this? Okay, okay, I just write like this, F to the ds. Okay, no dot product here. Okay, actually, okay, F here is goes without direction. That means it's not a vector. It's not a vector. Okay, this one is a what? It's a curve. Okay, arch, curve. Distance, we already calculated the length of curve or plane curve. Okay, plane curve. This is what we're going to learn in our method. Okay, I'm going to introduce to you method number 4. Method number 4 is an arch curve. Okay, Okay, now how do we able to, because just now I already briefly explained to you how to calculate the curve for the A and B. Okay, this is the calculations. Okay, del S. Okay, the length of this length can be calculated based on the del X. And since I already explained to you this one, the dy dx is referred to the f dx, and which basically can be equated to the del y del x, which I'm not going to refer again. I'm going to but to for the simplification, and I want you to understand these two processes. I'm just simplifying the whole logics a little bit, make it a simple del x del y del s. Okay, you can calculate this whole change of this in a small scale, del x to the change of the del y. Okay, therefore the length here can be substituted with this. Okay, substitute with this, and very obvious from here, the del s power 2 can be calculated to del x2. Okay, you agree with me? Okay, theorem Pythagoras. Okay, this theorem Pythagoras actually is a if you able to connect back to what you already learned before, this equation is actually referring to the equation that I want you to looking at here later. Okay, let me finish this part again. Okay, this one can be again explained as del x power 2, and del y here can be substituted as fx del x, okay, to the 2. Okay, and therefore I can take out, okay, I can take out then again fx power 2, right? Therefore this is 2 and the del x power 2. Therefore if I wanted to find out d, I can refer this as 1 f prime power 2. So this seems very easy. Yeah, why I didn't use that earlier? Just okay. Just to simplify the work again, ds, if it is a limit del approaching to the 0, okay, is a curve length. Okay, the curve length can be defined as, it change it to 1 fx prime 2 to the dx. Wow, easy. Okay, but I want you to get this logics, okay, because earlier I told you I wanted to show you why the parametrics works. Therefore you imagine ds to the dt power 2 is equal to dx to the dt plus dy to the dt. Okay, this is similar to this, right? Okay, okay, this is what we are doing. Okay, therefore you wanted to calculate for the ds. Okay, square root to this, because we can calculate the 2 plus dy dt, okay, 2 dt. Now you know why the parametrics is calculated as such. Okay, because in the early class, the previous when I start explaining this portion, where is this, there are 3 formulas that I introduced to you. One of the formula, okay, I cannot retrieve back. Okay, this recollect back this. Okay, this one I did explain to you what is this. I did explain to you here. Now you know why ds we are using parametric. Okay, now you know what is this parametric. Okay, now I already defined here how do we calculate for the ds for the parametric. Okay, hope that you can understand. From here also, if dt depends on an independent variable, it could be from here the ds depends the dt. Okay, for the dt, from here you can calculate the rest of the measurements can be calculated based on the depends. I wanted to put it that as a dx. If I wanted to change it to the dx, depends again, I tell you this is depend on independent variable. Okay, that could be dx or anything, therefore the ds can be changed. Okay, can be changed according to the dt and it become a 1, therefore easily it can convert to dy dx to dt dx. If I convert the dt in the form of dx, or then immediately I can calculate the whole equation to become like this. Okay, now you know the logics. Okay, how do we calculate this method 4? Okay, I'm going to introduce to you. Before I introduce this method 4 here, okay, this knowledge is important. Okay, based on that, now method 4 basically is a calculation of this. Okay, is what are we trying to do here is the length. Okay, we are calculating the length of del s, okay, without goes. Okay, this is without goes. You can see that no goes is moving on here. Okay, therefore this also later we call it that as a ds, but we are just identifying the length. Okay, the length calculations. Okay, we are referring the ds here. The ds is a very important calculations for you to know this equation and the calculation. There are various methods to calculate. Therefore this will be 1 f prime to the x, okay, 2 for the dx. Okay. If I wanted to calculate ds for the small case, how to calculate the s? S can be calculated, integrate. You just integrate, okay, for that particular point, maybe to the a to the b, okay, b to the a, okay, equation is f prime to the x dx. This is basically you able to calculate the s. Okay, therefore now the new formula that I'm going to introduce to you, w is a b to the a f ds. Okay, therefore the ds here is a small changes that we are talking here. Okay, again I sketch this part. Okay, what is f? F is a force without direction. Okay, this, okay, is a kind of ball, most probably rolling, but it's not in the direction, but is we just calculate the f of this. Okay, the f is it cannot be a force anyway. It carry certain scalar, okay, certain scalar, okay, of the it could be a weight or whatever, can be a magnitude, as long as you can understand this is a magnitude. Okay, which is, we are just saying that the weight, okay, the ball moving, running on this here. Therefore, can I calculate this? Can. Okay, remember f is a magnitude, it's not a scalar. Okay, therefore this sometime will be written as ds dx to the dx representation. Remember, there is a various way to represent. Sometime it will be written as ds dy dy. Okay, I'm writing various way how they represent this, right? Okay, now the new equations that we will substitute here for the work here to calculate the work continuously for the case here is something 1 plus f dy dx power 2 for the dx. You get me or not? This is a times, times, not a dot product. Okay, this is length of